Hello, this is going to be the first on 3 videos for quadratic functions. So when we say quadratic functions, we're talking about functions in the form ax squared plus bx plus c. And you've seen these pretty often. These are also known as parabolas. So our parabolas normally have some center point that we're going to call the vertex. And then they're always symmetric across the line that goes through the vertex. We won't worry about that line right now. The most important thing for quadratic functions is this vertex and if it crosses the x-axis. So in this picture, this example parabola doesn't, but if I have something like this, those 2 points are going to be important for our parabola or our quadratic function, and so will our vertex. So again, the important things, the vertex is always going to be there. It'll be the most important thing. And then sometimes we'll have it cross the x-axis and sometimes we won't. One last thing before I move on. This number a is going to determine 2 things for us. If it's positive, the quadratic function will point up, like our 2 examples over here. But if a is negative, it'll point down. So if we had maybe this 3rd example where we have this quadratic function, which is pointing down. And again, we still have the vertex. I won't worry about the stretching right now. The a also will determine how much the parabola stretches, but that's not as important as which way the parabola is pointing and knowing where that vertex is. So since the vertex is so important, we have a form where the quadratic function is already in so that we can see what the vertex is. And you'll notice this kind of looks like our slope-intercept form, a little bit. And this is going to be something that's common as we get into different and different functions. So our vertex is going to be the point h, k, that we can see from our vertex form. Again, like I talked about, a is going to determine how much it stretches or shrinks, so whether the parabola looks like this versus this. Again, we're not going to focus very much on stretching or shrinking. It's not going to change very much about the important things about a quadratic. The direction, we talked about that. If a is positive, it'll point up, and if a is negative, the parabola will point down. And then finally, we talked about if I have a parabola or a quadratic and it crosses the x-axis, these are going to be called my zeros of the equation, because these are the points where y, which really is the same thing as f of x, that's where this is 0. So the zeros of my quadratic are where the function is 0. Now, the thing about vertex form is it's really nice when I want to graph something from vertex form. For example, if I have y equals x minus 3 squared plus 4, it's very easy to give a general picture. The vertex is at 3, 4. My number in front here is positive. Right now it's actually 1. And so this points up. So with vertex form, it's very easy to graph the quadratic. And in this case, we can see that this quadratic actually has no zeros. It doesn't cross the x-axis. But we couldn't really tell that until we graphed it. So there's one last form that we'll see quadratics in. And that's in its factored form. So we'll have y equals, or f of x equals, this a, which is going to do the same thing for this shrink in direction. Our vertex we now don't know. It's kind of hidden. I can't see what that h or k is. But what I can see in this form are my zeros, z1 and z2. So the idea behind factored form is I want to use factored form when I really want to know what the zeros of the equation are. So for example, if I have y equals x minus 3 times x plus 4, what that tells me is my function has zeros at 3 and negative 4, right? Because I can write x minus negative 4. 3 and negative 4. I also know it points up, so I know it'll eventually do something like this. So the only other thing I would need to know in order to graph it would be that vertex. So we see if I want to graph a quadratic, I absolutely need the vertex. If I really just want to solve it, say I wanted to know where this function was equal to 0, it'd be way easier to solve it in this factored form than it would in vertex form. Right, we'd have to do a lot more work in order to actually solve this version than we would factored form. So these are 3 forms that we'll see our quadratics in. Again, our general form, or what we call standard form. Standard form tells us about A, but it doesn't really give us information about the vertex or the zeros. Vertex form, which gives us a lot more information, everything we need to graph it, but it doesn't help us to solve the function. And then factored form gives us some information about the graph. It's better and more used to solve equations because it doesn't have a very obvious vertex. We can't really see what the vertex is based on the form. And that's everything for quadratics.